let's start our chapter number 3, which is chemical bonding. So overview here is our key learning objectives. Understanding difference between elements, compounds and mixture. Explore various types of chemical bonding. Analyze properties of molecular and ionic compounds. Investigate structures of different carbon forms. Types of chemical bonding. First we have covalent bonding. So its description is it involves sharing electron between two atoms. Typically occurs between non-metal atoms. Electrons are shared to create stable molecular structure. Very important for examination point of view. The key characteristics of covalent bondings is electrons shared in outer electron shells. Forms molecule with specific structural arrangement. Enables information of compounds like water, ammonia and methane. Now let's talk about ionic bonding. Also very important for examination perspective. Its descriptions are involves complete electron transfer between atoms. So there is no sharing here. It is a complete electron transfer. Okay. Then it occurs between metals and non-metals. Creates oppositely charged ions held by electrostatic force. This concept also very important. So the ions are held together due to the forces called as electrostatic forces. Now ion formation process. Metal atoms lose outer electrons. So when they lose, they become positive ions, also called as cations. And then non-metal atoms gain electron. So they get negative ions called as anions with negative charge. So atom who lose become positive and the atom who gains become negative. The goal is to achieve stable noble gas electronic configuration. Now let's talk about ionic bonding rules. Electrons transferred from outer shell. Positive ion charge equal electron lost and negative ion charge equals electrons gained. Ions arranged in regular lattice structure. Now let's talk about metallic bonding. The description is electrostatic attraction between positive and metal ions. Delocalized electrons create electron C. It explains unique physical properties of metals. Now, ionic compound and their properties. The state. Crystalline solid at room temperature. Melting point high. Electrical conductivity. It conducts when molten or dissolved. Water solubility often soluble. Now let's talk about carbon structural forms like graphene highlights. Remarkable properties, extremely strong, 200 times stronger than steel. Excellent heat electrical conductor, transparent, highly flexible, potential technological applications can be built on it. Now we have carbon structural varieties such as graphite, diamond, fullerenes, carbon nanotubes and graphene. Key terminologies that you must know: cations. These are positive ions attracted to cathode. Anion, negative ion attracted to anode. Electrostatic forces, these are the attraction between opposite charges. Ionic bond, strong attraction between oppositely charged ions. Some visualization techniques like electron representation can be done by using dot and cross diagrams. You can show only outer shell electrons and you can demonstrate electron transfer and sharing. Some practical applications. Graphene potential uses include computer chip technology, water filtration, electrical conducting materials, semiconductor applications. Now let's talk about giant structures and chemical bonding. So giant ionic lattice structure. Key characteristics includes composed of positive and negative ions arranged in a repeating pattern, electrically neutral overall, ions always surrounded by oppositely charged ions. The structural properties include their arrangement, which is each ion is surrounding by ions of opposite charge. Example is sodium chloride NaCl is a crystal structure. Na plus ion surrounded by chlorine minus ions. Chlorine minus ions surrounded by sodium plus ions. Physical properties includes a hardness, hard but brittle. Layer interaction pushing layers causes repulsion when same charged ions meet, causes crystal fracturing. Now let's talk about dissolution and conductivity. Water interaction here, many ionic compounds dissolve in water. Water molecules surround individuals ion, break up the ionic lattice. Electrical conductivity conduct electricity when dissolved or melted. Ions can move and carry electric current. Now let's talk about giant covalent structures. Diamond, for example, the structure is carbon atoms arranged tetrahedrally. Each atom bonded to four others. Tetra means four others. Properties include extremely high melting point, very hard, no electrical conductivity, and no free electrons. Important for examination perspective. Now let's talk about graphite. The structure is they have flat layers of hexagonal carbon atoms, strong covalent bonds within layers, weak forces between layers. Some unique properties of graphite is like it's soft and slippery, conducts electricity, has free electrons that can move between layers. Now let's talk about silicon 4 oxide. The structure similar to diamond's tetrahedral arrangement. Silicon atoms bonded to oxygen atoms. The properties include very hard, high melting point, and does not conduct electricity. Now let's talk about metallic bonding. The structural model is that metal atom lose outer electrons. Positive ions in a sea of delocalized electrons. Electrons move freely between ions. Some physical properties include high melting boiling points, strong electron ion attractions. Then electrical conductivity, mobile electrons carry current. Then malleability and ductility, layers can slide over each other, new bonds easily formed. Now, bonding type summary. In ionic bonding type can be participants, metal as well as non-metals. The key characteristics here is electrostatic attraction between ions. Second is covalent, non-metal and non-metal. So shared electrons. Metallic, here we have metals and then delocalized electrons. Key terminologies here is giant ionic lattice, which is electrostatic forces between ions. Giant covalent structure, which means large number of atoms bonded in a lattice. Metallic bonding, electrostatic attraction between mobile electrons and positive ions. Now let's talk about chemical bonding. Overview of chemical structures. Key distinctions: elements, compounds, and mixtures have fundamental differences. Understanding bonding helps predict material properties and its applications. Let's talk about covalent bonding characteristics. Important, okay, very important for exam perspective. The definition is formed by sharing outer electrons between atoms, visualized doing dot and cross diagrams, can involve single or multiple electron sharing. Now, representation technique, ionic bonding. Formation process occurs between group 1 metals and group 7 elements. Electron transfer, metal ions, which is cations, and non-metal ion, which are anions.